Hello friends, in the last lecture we have discussed about the positive and the negative work with the help of the PV diagram. And now in today's lecture, initially we are going to discuss about the quasi-static systems. Now we know that a system changes from its initial state to some final state. Now, when the system is changing, supposing when this change is taking place, if heat is gained by the system from the surrounding, that this is positive heat. If heat is lost by the system to the surrounding, then this is negative heat. Also, the changes are also of type work is done by the system. The work is positive work. If work is done on the system, the work is negative work. Now, all these changes are taking place in a system, and the system is in thermodynamic equilibrium. We have discussed about the thermodynamic equilibrium in the initial lectures. We know that. So, now, whatever are the changes in the system which are taking place in the thermodynamic equilibrium conditions, and if these changes are occurring infinitesimality slowly, that is very slowly, खूप हळू changes होत आहेत हे. So such system is called as quasi-static system. The process, quasi-static process, it is a process in which the changes in the system which are occurring in thermodynamic equilibrium conditions, the state variables, the changes in the state variables of the system occur infinitely slowly. That is very slowly. The system is in thermodynamic equilibrium. Then such process is called as a quasi-static process. When a thermodynamic system changes from an initial state to final state, it passes through a series of intermediate state. This series of intermediate state, when plotted on the PV diagram, is called as the path of the system on the PV diagram. The path shows the way the system has gone through. The next, we are going to discuss about the work done during a thermodynamic process. A system changes from point A, which is having pressure Pi and volume Vi, to the point B having pressure Pf and the volume is Vf. We would understand the relation. We would discuss the relation about the path and the work done during the path. We will consider three different ways in which we can change the state of the system. So, the first is the system which is at point A and which comes at point B by the first way. That is, we have written here 1. That is, the volume decreases. That is, here the pressure goes on decreasing and the volume goes on increasing. This is the first way with which we can change the state of the system from A to B. The pressure and the volume are changing simultaneously. The second way to change the state of the system from A to B is the pressure is kept constant initially. The system comes from point A to point C, and then the system, and then after coming to point C, it comes to point B. That is, now here the pressure is kept constant and volume is increased. Now at point C, it comes to its final volume, and in this way, in the second path or the second way, from point C, the system comes to point B. That is, now the volume remains constant, but the pressure of the system goes on decreasing up till it comes to the point B. So this is the second way in which we can change the state of the system from its initial state A to the final state B. The next, that is the third way in which we can change the state of the system, is the system comes from initially the pressure of the system decreases and the volume of the system remains constant. The system comes from point A to point D. Now, the pressure of the system remains constant, remains same, and the volume of the system goes on increasing up till the system comes to the point B. So in this way, these are the three ways in which the system changes from its initial state A, that is pressure Pi, Vi are the initial pressure and volume, to the final state B, that is Pf, Vf, that is the final pressure and the final volume. Now, we will discuss each method, each way separately. So, we will discuss the method 1. So, here on the y-axis is the pressure and on the x-axis is the volume. Now, the system, we are going to discuss the method 1, in which the pressure and the volume are changing simultaneously. The system is at point A initially, having pressure Pi and volume Vi. It changes from point A to point B. Here, the pressure goes on decreasing, the volume goes on increasing. Now, the work done is the area under the curve A, Vi, Vf and B. Now here we know that the volume of the system has increased. So the work done is a positive work done. In the method 2, again the system is changing from point A to point B, but its path is from A to C and C to B. So the system changes from A to B. Now here initially the pressure is remaining constant and the volume is increasing when it is moving from A to C. That is, the volume increases from A to C. The volume is increasing from Vi to Vf, and the pressure of the system, which is Pi, is remaining constant. Now, when the system comes at point C, its volume remains constant and pressure goes on decreasing. So, the pressure decreases from point C to point B, that is Pi to Pf, and the volume, which is Vf, is now remaining constant. Now, the system has come to point B. The system was initially at point A, it has come now to point B. Now, the work done during this the change from the change of state of the system from point A to the point B, the work done is the area of the shaded portion. The area of this shaded portion, that is Vi, A, C, Vf. This is the area of the shaded portion. So this is the work done in the method 2 by the system, though it changes from the same position A to the same position B. The method 3, again the system changes from A to B, but now its path is different. So from A, the system comes to D, and from D to B. That is, the system changes from A to B. But how? Initially, the pressure changes. That is, the pressure decreases from Pi to Pf. Pressure decreases from point A to point D, that is from Pi to Pf it decreases, but at this point the volume Vi remaining constant. Now, the next is the volume now changes from Vi to Vf, but the pressure remaining constant, that is Pf, the pressure remaining constant. The system now arrives at the point B from the point A. Now, the work done by the system is the area of the shaded part, that is the Vi dBVF, that is the area of the shaded portion. So we have discussed three ways in which a system would change from an initial state to the final state. We have seen in the method 1, method 2 and method 3 that the amount of work done in all the three methods is not the same. So we conclude work done by the system to change from the initial to the final state does not only depends upon the initial and the final state, but also it depends upon the intermediate state, that is the path along which the change is taking place. Thank you.